All right, and welcome back. So today we are going to be furthering our conversation about how to rewrite equations into standard form. There is an example done at the top of your page for this one, so if you want to look through it, by all means, it's going to be a fantastic example and a step-by-step example. Now, with that in mind, I am going to be going through two other examples for us to work on while y'all are going to be working on the other couple of problems. So, without further ado, let's begin. Let's talk about problem number 15. Problem number 15, we are given that we have a coordinate point 6, 8, and we're giving m is equal to 2. One of the first things off the bat that I notice is that I have m is equal to 2. Thinking back, we know that m stands for slope. So it's going to tell us that whatever line we have is going to have a slope value of 2. I also notice that we are given a coordinate point. We have 6, 8. Let's think back to what we know about coordinate points. We know that each coordinate point has an x, y, so we can identify the x value and the y value. The x value is 6, the y value is 8. And this reminds me of something that we've done in the past. We're given a point and we're given slope. So maybe we can use these and think back to writing linear equations if we're given a point and the slope. Oh, point-slope form. We're going to be able to use this point and the slope in order for us to write an equation in slope-intercept form that'll then allow us to manipulate it into standard form. So let's quickly recall slope-intercept form is of the form y equals mx plus b, where m is your slope and b is your y-intercept. Looking at what we're given the x, the y, and the m. So let's go back and substitute in those values just like we've done before. We have 8 is equal to our slope, which is 2, times our x value. Our x value is 6. And still plus b, because we do not know the y-intercept. So we're going to solve for it. Well, we can do 2 times 6, and that gives us 12. So we have 8 is equal to 12 plus b. We drop everything else down. And now we want to isolate that b term. So in order for us to do that, we have to subtract the term we do not want. We do not want the 12. So we have 8 minus 12. 8 minus 12 is negative 4. Therefore, our b value is negative 4. Now that we know our intercept, our b value, we can now rewrite this in slope-intercept form. Well, slope-intercept form is y equals mx plus b. Our slope is 2. And our y-intercept is negative 4. So this is currently in slope-intercept form. But again, the directions are asking us to write in standard form, which is ax plus by is equal to c. Don't be lazy now. This is tedious, but we know you can do it. And you know you can do it, but you need to make the choice to continue on through. So what I'm going to do, I'm going to rewrite everything. I'm going to bring it on up. That way we have a fresh side to look at. We're starting with y is equal to 2x minus 4. And we want to get our x and y terms on the same side of our equal sign. Well, if I just draw a quick line, let's dash it. Going through the equal sign, we need to have our x and y to the left of that line, because that would mean they're both on the same side of the equal sign. In order for us to do that, we need to move this positive 2x to the other side. To move a positive number to the other side, we subtract it. We want to change it into 0. We cancel. And we cannot combine y and negative 2x. They are not like terms. So we're going to rewrite it as negative 2x plus y is equal to negative 4. And this is how we write in standard form. So on the left-hand side of our screen, we use the given information to help us. write in slope-intercept form because we know how to write in slope-intercept form when given the point and a slope. Then we took that equation slope-intercept form and manipulated it into standard form. So with this in mind, please work on the next couple of problems and resume the video when you're ready to go over another example. All right, let's talk about problem number 18. One of the things that I notice about problem number 18 is that we're given two coordinate points. The first thing that I think of when I'm given two coordinate points is I know I can calculate the slope. We know how to calculate the slope between two coordinate points. It's the change in y over the change in x. As a quick refresher, the second y value minus the first y value divided by the second x value minus the first x value. Let's identify what our x's and our y's are within the coordinate points. 6, -4 is the first coordinate point that appears. 7, 1 is the second coordinate point that appears. So I'm going to label my 6 as x sub 1, and you should be doing this as well. The -4 as y sub 1, because that's the y value and the x value of that first coordinate point. 7, 1, 7 is going to be x sub 2, and 1, pardon me, is going to be y sub 2. Those are the x and y values of the second point. We can now go in and substitute in some values that we know. Well, y sub 2 is 1 minus y sub 1, which is -4. Notice how I'm putting that value of -4 in parentheses because I don't want to confuse myself knowing we have subtraction. We need to include -4. It's 1 minus that y value, and that y value happens to be -4. Divided by the second x value, which is 7, minus the first x value, which is 6. When we solve 1 minus -4, this really changes to plus plus, so we end up with 1 plus 4, which is 5, 7 minus 6, which is 1. We have 5 divided by 1. We know we can simplify that, and we have 5. Thinking back to what we've done before, and we're talking about the same page of slope-intercept form. We know how to write a linear equation when given points. We calculate the slope, and then we choose a coordinate point to use. So we're going to mimic the process that we used in the last example in the last couple of problems, but we have to choose a coordinate point that we want to work with. So for all intents and purposes, I'm going to choose 7, 1 because both of those numbers are positive, and I like to stay as positive as I can, and I'm positive about that. So we write slope-intercept form, y equals mx plus b. And we're going to substitute in the values of our x, y, and our slope. Well, we just calculated the slope, again, which is 5. We have our x and y values from the coordinate point. Our x is 7, our y is 1. We're going to substitute in everything we know. The y value is 1. The slope is 5. The x value is 7 plus b. We can multiply 5 times 7, which is 35, and we drop down everything else. We want to isolate that b term, so we're going to have to subtract 35 on both sides. In doing so, those 35s cancel out, and we're left with 1 minus 35, which is -34. That's equal to our b value. And we can rewrite in slope-intercept form. Y is equal to 5, because that's our slope, x minus 34. We box in our answer so far, and we're going to do exactly what we did before. We're going to create some space here. I'm going to rewrite it. That way it's easier for us in the long run Takes a couple extra seconds, but those couple extra seconds are well worth it. Now remember, we're trying to write in standard form, which is ax plus by is equal to c. We want to get our x and y's on the same side of the equal sign. And again, if I were to draw a dashed line going through that equal sign, they're not currently on the same side. So we need to move that positive 5x over to the left-hand side. In order for us to do that, to move a positive term, we subtract it. So we subtract 5x on both sides. Therefore, those original terms cancel out. Negative 5x and y are not like terms, so we cannot combine them. So our final answer turns into negative 5x plus y is equal to negative 34. And that, kiddos, is how we write in slope-intercept form and change it into standard form. Y'all are doing a really good job. Keep up the great work. Keep making yourselves proud. If you have any questions, please do not hesitate to let us know. Please let us know if you have any questions in the box provided, and we will talk to you soon. Keep up the great work.